Hi, thank you very much and welcome. And it's amazing to see how many people have come for the workshop today. So yeah, get yourself all seated and we'll get started. Brilliant. So how is everybody at coding at 9 a.m. in the morning? All good? Hands up if you're a lark. Any owls? No? Well, we'll try and go easy on you owls, and let's just get started because we've got loads to cover today. Because we're looking at, it's quite a big topic, but we're going to try and simplify it down. It's Retrieval Augmented Generation, and this is an introductory workshop, and it's meant to be for people who don't really have any RAG experience, but you'll need some Python. The aim today really is, I don't think we'll complete everything in the exercises today. Some of you will, some of you race through it, but some of you won't, in my experience from running a few of these. But what I want you all to do is to leave the session with enough information to go and be able to do RAG for yourself at home. And you'll have a nice exercise to take home with you and complete if you don't manage to complete it today. All right. Tom Bay introduced me. My name's Dan Gibson. I've actually, I turned 50 last year, 51 this year. So yeah, I've been coding since 1983. Started on a Commodore 64. I found Python about 7 years ago. There was a first sort of mini AI renaissance when AlphaGo and IBM Watson came around, and I started looking at this. I thought, this looks really interesting. And then the language of choice was Python. I thought, I'll get into that. And my first project was to build a bot that would predict the results of football games by using historical football data. I called it Motson. You see what I did there? Yeah, so it wasn't much of a competition for IBM Watson, but since then I've been doing quite a bit of stuff. But most recently, about 12 months ago, 14 months ago, when ChatGPT first came to prominence, I looked at it. I thought, wow, there's a lot of things we could do in the sector that I've done most of my work in my life, which is retail e-commerce. And I thought there's so many applications for large language models, and I started experimenting with the sort of use cases I could do in retail e-commerce. And so I started, one of those experiments has become a product that I'm developing called Personified Chat, which is basically an e-commerce virtual sales assistant. So our company basically builds that product and offers services for custom building, advice and training as well. All right. I've done quite a bit of training in my life. I generally like to have a few working agreements with the class. And this is a massive class. So it's probably the biggest one I've ever taught in a coding scenario. And actually apologize if you have problems today and I don't get round to all of you, I apologize, but there's a lot of people here. It kind of makes me think I should take some volunteers next time to help run around and answer your questions. But within this session, stop me if you have a question, because I don't want you to feel like you're kind of going in there blind, because there's a lot of stuff to do. When we're in this sort of a scenario, one conversation at a time is great. Obviously, when you go and start doing the project work, then there'll be lots of talking. If you've got a question that's a bit off topic, loads of time today. I'm around all day, so just come and grab me afterwards. I might just park questions that aren't going to help the rest of the class, but I'm available all day or on LinkedIn. And the other thing is, we've all got different abilities. I'm absolutely sure there's so many people in here who are much better coders than me. So, help each other out. And that's one of the things I think I kind of like. It's a bit big today, this class, to sort of organise something a bit formal, and we're quite pressured for time. But if you've got the opportunity to pair up with somebody next to you or work in a three, I'd do it. Because actually that's really helpful to exchange ideas. It's also really helpful from a practical point of view, because actually one of you can have the exercise text open on one computer and another one of you can have your IDE open on the other doing the code, right? And so I think it really helps if you're not in a pair, just grabbing a pair or a 3 or a 4, whatever you want to do. So that's quite good. And then just work out, have a big fight over whether you're a PyCharm or a VS Code person, whichever IDE you want to use. Okay, all right. So today, what we're going to do, well, first bit, you probably already know what Retrieval Augmented Generation, RAG, as I'll refer to it from now on, is. So we're going to go just do a quick introduction about RAG. Our second section talks about some of the essential tools which we need if we want to do RAG successfully, which is using vector databases or vector stores, indexes, whatever you want to call them, and text embeddings. Then we're going to look at a concept later on in section 3 about how you take a big chunk of text and how you take a big body of text and chunk it into different smaller bits of text so that you can store it in a vector database, then retrieving it later. And we finish up by actually building a bot that can actually answer a question based on a body of text. All right? Right, so who here has, I guess, have you all heard of RAG? Yeah, good. So essentially, you probably all know then, it's all about taking large language model responses and enhancing them with your own input data, all right? So it's about you kind of directing the answer of the bot by using data that's within, within your own organization, all right? So there are many reasons to do this. So one thing's, what we do at Personify is we work with product catalogs and we inject those into the conversations with large language models. So we inject organizational data, we inject, in this case, a product catalog into the conversation. It means the bot can also answer questions, it can also make decisions based on the data that you've got. So, we've got an e-commerce case there where we're asking a question about that product. If you're an insurance company, you might have somebody internally or a customer asking a question about a policy. It's all about directing the conversation using the data that you want. There's also a really good reason to do this. Previously, if you rewind 5-6 years and you look at chatbots out there in different organizations, generally they're kind of restricted. The capable chatbots were restricted to organizations with deep pockets who could afford to train bots based on their organization's data. We can do a lot these days without actually having to train a chatbot. So we can actually do a lot of the functionality that you used to be able to do in a very expensive way by training bots. You can do that now quite cheaply without having to train LLMs and using this wonderful technique called Retrieval Augmented Generation, which is why it's become really quite popular. We're going to deal with a really simple RAG use case today. RAG can get really complicated, and if you look online, you'll find diagrams which are full of information about what is RAG, and it will give you lots of different flows and lots of different tools. I want to just keep this really, really simple, so it's a good introduction. Starts off with a user question generally. And what we do is we query a data source based on that question. In this case, the data source we'll use today is a vector database. We use that data that we get from the database to inject the data into the conversation that we have with the LLM. All right? And within that LLM, we have a combination of an instruction to the LLM and the data. I can make this a bit more clear for you. Hands up if you've used the playground, OpenAI's playground. That's a lot of you. Good stuff. So the playground, and it's going to be the first exercise today, and this really helps to give you a kind of feel for what RAG is about. Many of you that you've used these things will know that there's this sort of background message called a system message, and this is generally where we do any kind of instructing of the bot that we don't necessarily want the user to see. So in this case, we tend to give the bot an instruction. So in this case, we're telling the bot, you're an expert sales assistant, you're helpful and knowledgeable and friendly, and your aim is to find the best product for customers and explain why it'd be a good choice. Customers will ask you questions about products, answer it based on this information. So you've got a fixed instruction and you've got data that varies each time based on the question the user's asking, right? So if a user's searching I'd like to find a pair of blue trainers, a search will go for blue trainers, inject the data into there, and then, you know, your bot will answer the question and engage in a conversation with the user. In these conversations, you generally call the user and the bot the assistant, all right? So then you engage in a conversation about that data. And both the instruction and the data is hidden from the user, okay? So that's the basis of RAG, and you can do it with structured and unstructured data as well. So in the previous example, I just showed you some JSON, which was a product catalog, which is the sort of thing I do on my bots all the time. But today we're going to use unstructured data, because actually what is so immense about the tools that we've got today is that they really allow you to work with unstructured data in ways that you've never been able to work with it before. And vector databases really do enable a lot of functionality that wasn't previously available. So we're going to explore that and explore a RAG scenario with unstructured data. Here's the unstructured data. So, apologies, I'm not a flat earther. I have to, hands up. But what I wanted was, I wanted to show you that actually we can inject information into the conversation that would be atypical of the answers that a normal chatbot would give you. So we've chosen, and funnily enough, this book is free as well. So 100 Proofs That the Earth is Not a Globe, available freely online if you so choose to get it. But luckily, you get it all in the download packs that you've just downloaded if you came in before the session. Some of you have looked at the repository. So what we're going to do is we're going to do a bot that answers a question like this. It's like, this is a perfectly reasonable question to a flat earther, I think. If the Earth is flat, why does only the top half of a ship appear when the ship is at a distance? Couldn't be the curvature of the Earth, could it? No. Your bot is going to answer that question with an answer like this, all right? Oh yeah, here we go with the same old misconceptions. It's not about the Earth being flat that causes the top half of a ship to appear at a distance. It's about the perspective and limitations of human vision. All right? Fantastic. All right. So, who's managed to download the repository yet? Hey. If you haven't yet managed to download the repository, either sit next to somebody who has, or just go ahead and get the repository from github.com/personify.ai RAG short intro. There's Leonardo Guest Wi-Fi, if you're not on the Wi-Fi yet, is also the Wi-Fi that you should be using. All right. I'll give you 2 seconds just to capture that, and then I'll move on. All right, is everybody ready for me to move on to the next bit? Yeah? All good? Okay, so our first exercise today, so if you go to the MD file, you'll see that everything is organized around the exercises. So there's a separate folder for each of the exercises. All right? Exercise 1 isn't going to have any coding involved, which, you know, we're going to start you off nice and easy, get the brain nicely oiled before we move on to the hard stuff. So within each of those exercise folders, you'll see an exercise.md file, and it will just give you instructions, some really easy instructions to follow through. And in this exercise, all we're doing is we're going on to that OpenAI playground that I showed you. what we're going to do is we're going to use the system message, which is there, which remember that is the background message that the user is not really seeing. And we're going to enter an instruction. We're going to give our bot an instruction, and we're going to paste some data in from the MD file. Not from the MD file, from the repository, which is this flat earth extract text. So this text is governed and it's selected particularly to answer that question about, if the Earth is flat, why does only the top half of a ship appear when it's at a distance, right? So there's particular sections of the book that are picked. And this is just to show you, because we're going to use the API later on, and this is really that session, this chat playground here has got all the kind of parameters that you'd find in the API, all right? So when we go and actually use the API, you'll be replicating some of the prompt engineering that you did in this section when you go to use the API. So have a look through the MD file, grab the repository if you haven't, and then, if you need any help, just put your hand up and I'll try and run around. If we can do this in about 5 minutes, that would be great. All right. For those of you that made a bit of progress, I know we get a few issues with people running out of credit. If you have to put a bit of credit on there, it's literally by the minimum you can, because it's like we will use pence on this. So hopefully you got a chance to do that and experiment with the system message and experiment with injecting data into there. So what we're going to talk about now is we've kind of shown you the bit of the process about oh, hello. All right, just going on to this bit. We sort of showed you the process of crafting your system message, then putting data into the conversation so that and you should have seen, when you finish that exercise, the bot would have answered the question based on the data that you put into the conversation. All right, now that's going to be important, and just keep a note of what your prompt was for later on, because we're actually going to do this for real in the API later. Right, here we go. So what we're going to do basically from this point onwards is we're going to take you on a journey. Firstly, we're going to have a look at the vector databases and things like text embedding. How do we get, you put a very specific part of that text into the conversation. So, the hard bit of this, the really hard bit of this is actually being able to get the right context out of a data store to inject into the conversation. And this is what we're going to do next. We're going to face into that problem now. And the way we do that is with vector databases and something called text embeddings. So vector stores, sometimes called vector indexes, sometimes called vector databases. Take your pick. They're all roughly the same thing. And text embeddings, and we're going to kind of demystify those at the moment. So I'm pretty sure, being in a room with a bunch of data scientists, you all know what vectors are. It's basically, it's a mathematical entity that has magnitude and direction. I like to explain them to sort of people who don't know what they are with the analogy of a colour. If you imagine like a RGB colour space, you'll know that if you want something like yellow, you're going to have to max up your green, max up your red, and put a little bit of blue in there, and then you've got a nice yellow colour. All right. So basically, a vector is always pretty much represented like this as a bunch of numbers. In Python, you'll find it's all usually in a list. And the different, and that one's a vector with 3 dimensions. We're going to be dealing with vectors later on of 1,536 dimensions. So, just remember that number. It'll be important. With vector databases, I mean, I guess a lot of you use just standard RDBMSs and SQL. One of the things you'll be used to when querying that is you're querying for kind of exact matches a lot of the time. So, it's like select star from employees where first name equals Dan, you'll get some exact matches. Vector databases aren't like that because you're not looking for an exact match most of the time. What you're looking for is the closest distance from the vector. So if you did a search for this yellow color, you know, you'd be expecting to retrieve as many results as you want, a figure that you set, of the vectors that are closest to it in distance. And there are different distance measures. And those are important things to remember. And the one that you're going to have to remember is cosine, because when we're dealing with the vectors we'll be dealing with today, the distance measures that they're optimized for is the cosine similarity. All right? So just remember 1536 and cosine, and you've got all the information you need to set up your vector database. All right? Example of vector stores or vector indexes, vector databases. I use a lot of Weaviate, but I find it really good, and what it does, it simplifies a lot of the functions for users, and it also, but the thing is, it obfuscates a lot of the usage of vectors, which I want to expose you to today, so you know what's going on behind the scenes. I can recommend that database. I use it all the time, but today we're going to be using something called Pinecone, which is also a really good vector store. Both of those have got a really good reputation. If a lot of you are wondering what a vector store to have in your own organization or with your own work, you might want to look at what database you use, because what's becoming a big trend these days is not to have a separate vector store, but for the standard RDBMS makers out there to actually implement vector indexing on the within their own databases. So for example, PG Vector's got a really good vector indexing scheme that you can just apply if you're doing what a lot of people do who are operating the Python domain and using PostgreSQL, right? Okay, fantastic. So we'll be using Pinecone, and this is what the exercise will be about later. So within the exercise today, we're going to teach you basically how to use some basic Pinecone facilities, and most of the stuff you have to use is pretty basic actually. One of the things we're going to have to do is create an index. A vector index is the index which stores all your vectors. And to set up your index, you need the dimensions, 1536, and I'll tell you why that is in a minute. And you also need the metric, which is a cosine, which is the sort of distance metric that text embeddings are optimized for. All right? So one of the things we are going to have to do is we're going to have to create our index. The other thing we're going to do is something called upserting data. Can you see what they did there? It's like, it's an update and an insert. So what happens in a vector database is, like, all the vectors are unique. If you add in the same vector again, it just overwrites an existing vector. All right? Okay, so what do you need when you do an upsert? Well, you need the vector, and we've got a very simple vector there of, I don't know, it's 8 or 10 dimensions. And we've got some metadata, which is really, I think it's more like data. But basically, this is the data that is sort of supporting the vector. So when you're going to be uploading your vector later on, you'll be uploading a body of text. So the metadata you will store in this will be the actual text, and the vector will be the vector representation of that text. All right? When you query, so 3 things we'll be doing today: creating our index, putting some data in it, querying it. When you query it, very simple again, all you need is the vector that's going to be your input vector for your query. It will return the closest matching vectors within the database, and it will return as many results as you want. So make it 3, make it 5. And you usually want to include the values in that return as well, so you're including that metadata. All right? Because that allows us to see what data we've stored in relation to that vector. So like I said, we're going to be using something called text embeddings. So we will be storing text embeddings in our vector database. They're basically they're like a vector representation that stores the kind of semantic meaning of the text, so that you could actually just get some kind of numeric representation that gives, that actually records what that piece of writing actually means. It's pretty amazing, really. It's all magic. If I was to embed this text here, then I would get that vector. That's a vector which has a dimension of 1536. So that's a vector representation of the text you see there. All right? And that's what we'd store in our database. All right. So what does it allow you to do? So what it allows us to do is it allows us to pick other bits of text that have the closest meaning. So in the next exercise, what we're going to be doing is uploading, and it's an experimental exercise, so it's not about the book this time. This is just to get you used to handling the database. We're going to upload a load of questions. And they're all questions related to an airport. So show me the airlines that fly between Toronto and Denver. You know, show me what the ground transportation is at Boston Airport. Right. So we're going to upload about 7 or 8 questions, and then we're going to query that vector store. And what it'll do is it'll pull in the most similar questions to your question that you are asking it, all right? So it pulls in the most similar text. So what happens is, if you were to compress that 1536 dimensions into just 2, you would see that actually what happens in this vector space is that things with a similar meaning occupy the same dimensional space, all right? So this is the power of them. A vector won't tell you what the text is actually itself. It's a one-way street from the text to the vector. But what it will do, it'll enable you to put in a bit of text and say, these are the most similar bits of text I've got in my database to your query text. All right? Is everybody happy with that? Because that's a core concept. But you'll be trying it out in a minute. All right? Okie doke. So, like I say, text to vector is only one way. You're never going to be able to get a vector and go back to the text. But what you can do is use a vector to search for similar vectors, and if you've stored the text against those vectors, you'll be able to get, you know, the most similar text to the text that you're inputting in the query. So one of the things we've got to do is, in the next exercise, you'll also be creating these text embeddings. We're going to use OpenAI to do that, and we're going to use OpenAI's embedding model, and it's text embedding 3 small. And what we do is we basically put our text as an input into that, and then we get back a vector representation which is stored in a data element 0 here in the embedding. All right. The next exercise is going to be, it's probably the hardest exercise, so don't worry too much. It's going to involve having OpenAI and Pinecone and linking to those folks. You've got 2 files. Oh, untrusted server. Right, so we've got 2 files, load embeddings, where we're actually going to go and load stuff into the Pinecone database. There's basically 3 functions in there. There's a get embedding function, which basically gets an embedding and gets that 1536 vectorized representation of your text. And we're going to load these questions up into the database. So there's there's about 8 or 10 questions there. Going to load those into the database by actually creating an index, which we do in this first function here. The only thing that you have to do is put in the dimensionality of that index. So yeah. Yeah, sorry. Yeah, here we go. Yeah. All right. So we're going to basically create an index. You'll just change how many dimensions are there, and then you'll just run it. I put to-dos wherever in this code of stuff that you have to do. So basically, yeah, try out this function. What I want you to do first off is try out the embedding and see how it comes out. and then uncomment that to do, and then you can create, it runs the create index and load questions, and then that will just set up your vector store for your questions there. And then the next, do that, and then the next bit is all about querying those embeddings. All right, so we've got another part of the exercise which is about querying the embeddings then. All right, okay folks, are you all right to move on now, is that right? Yeah, look, I know some of you have some little problems with this exercise and some of the other exercises, but actually, you know, what you've got is something that you can take home here, and you know, we have this session so you can hear all the kind of theory and context that I can give you. So hopefully some of you will have got through that exercise, hopefully some of you will make a good indent into it. But what you should have seen there is you'd have got experience of looking at embedding some text and getting all those 1,536 dimensions of a vector back that are the representation of it. You should have had a go at uploading some of those questions into the database, and you would have seen the Pinecone database in the background with all your vectors in it. And then you would have, when you're doing a query, when you're querying that database and you queried with, what can I get a taxi in Boston, you know what you've got to do first off is you've got to vectorize that bit of text you're putting in as the query, then you're matching that vector to the actual, you're doing a query against the vector database to get the top 3 or top 5, whatever you put in that top K as the results back, all right? Everything is going to make more sense in a minute as we go, and you might go, why are we doing this? We'll show you in a minute in this section here. There were some really good questions in there. There was like, why are you using 1,536? Why are we using a cosine metric as the distance calculation? Well, there's good reasons for that, and the good reasons are that, you know, whenever you're looking at using an embedding model, find out what the dimensions are, what distance metric it's optimized for. It will usually be cosine, but you need to know those things if you want to use that embedding model effectively. So those things are governed by the embedding model that you use, and we're using that OpenAI one, which just happens to be 1,536 dimensions and optimized for cosine similarity. All right? Fantastic. Great. So what we wanted to do there is get you some experience of just playing with a vector database. Now that, for all intents and purposes of us building a chatbot which argues emphatically for the case of a flat Earth, throw that knowledge away now. Just consider yourself a bit more capable at dealing with a Pinecone database index, and consider yourself familiar with text embeddings. And we're going to use that in the next section, because you might be thinking, well, what am I going to use this for? So what we're going to do is we're going to store that text, 101 proofs for a flat Earth. And the way we do that is we store a large piece of text by chunking it up into smaller pieces of text. All right? So you take a book and you break it apart into chunks. So you take a large body of text, and then you'll usually chunk it up into either sentences, paragraphs, or slightly larger sections, or sections that have some coherence. All right? We're not going to be too fussy with our chunking when we do this. We're going to use something called LangChain text splitters. If you want to get really kind of into the chunking, you might want to do something a bit more custom, but LangChain, I don't really use it for much, but I do use it for this sometimes. So you will need to pip install LangChain, all right, for this next exercise if you haven't already. And what we're going to use is something called the recursive character text splitter. And what that does is it chunks up things into basic blocks of about 1,500 characters, but also does an overlap of 500, so that we kind of don't miss holding context with it, you know. So, you know, it's just basically trying to do a bit of overlap. So when we go and interrogate that database, you know, we kind of, it gives us a bit more confidence that we're going to get a sort of semantically coherent piece of chunk to go to inject into our model later. So the idea is, what we're doing is we're breaking that book up, we're breaking it into a load of different chunks, we're going to store those chunks in the vector database, And then at the time of the query, when we do our bot later, our bot is going to answer a question. We're going to go to the vector database and retrieve the most relevant chunks of information to answer the question and inject them into the model, which saves us having to inject the whole book into the model, which you wouldn't be able to do in most of the OpenAI models. All right? Okay? Does that make sense? So what we're going to do is we're going to use these lang chain text splitters in this next exercise. And what we're going to do is we're going to split the book into a number of chunks. And those chunks are going to be 1,500 characters in size. They're going to overlap by 500 characters, which will ensure that we manage to sort of maintain relevant context within all the chunks. And we're going to load those into our Pinecone database. So you'll be creating a new index. What will be the dimension of the index? Yeah. What will be the distance metric? Yeah, you're good. This was I've managed to impart some information today, so I'm happy. All right, brilliant. So the next exercise, exercise 3, what you'll find in there, and I'll just go to the exercise now. You'll find this load chunks piece of code here. This will basically load chunks up into the database from this text here, which is flat earth text. That, and don't say you don't get nothing when you come to one of my training sessions, you get a whole free book, 101 proofs for flat earth in a text format, which you can load into your database. So that load chunks is basically going to split that into chunks. It's going to load it into a Pinecone index, create a Pinecone index for you and load it. Once you've loaded it, there's a retrieve chunks section there, and you can use that to test your queries, right? And test, which is an important thing, because this is the hardest part of RAG, is making sure you get the right contextual information back. You can throw out some questions. I've got some sample questions in the MD file there. If you throw those questions at it, you'll see that you should get the right stuff back. There's only a few things you've got to do in that load chunks. The only thing you've got to do is you've got to put the chunk size that you want to play with in there. That's the only modification you have to make to that file. So I will let you get on with that now. Good luck, and just put your hand up if you need some assistance. Right, folks, how are you doing with that? All good. If you haven't finished that exercise yet, you will have the chance to finish it because we're using that same function. How many people got to load their data? Yay, Ray. How many people got to query some data? Was it all working good? Yeah. There was a really good question over there actually during the session, and they said, oh, that chunking model, what does it do? And I usually do tell people, but I'm not really a morning person, and so I did forget. Really that chunking model tries to keep the chunk sizes around 1,500, but it optimizes basically on, it looks for gaps in paragraphs, then gaps in sentences, then gaps in words, and tries to keep things together, but also keeping it around 1,500 characters, all right? So just to let you know, that's roughly what that lang chain text, the recursive text splitter is. So it's not usually a hard 1,500, but it's looking for good gaps to break the chunks on, all right? Okay, fantastic. So what you should have done there, and understand if you don't finish it, but what I want to do is at least get the last section done so that you get all the context and you can take the exercise home and finish it in your own time. What you did there is you basically took that book, 101 proofs, you broke it down into chunks, you vectorized all those chunks and you loaded it into the Pinecone vector database. You now have a vector store that has your book in lovely chunks that you can now query. So when you put a query towards it, and those of you who got onto the query section, you'll have seen you can put in a query and it should retrieve the chunks that are most semantically similar to your question, the chunks that can answer your question. So we are going to do the next bit now, which is actually finishing off the bot. So we're going to be doing generating answers with OpenAI. So we'll be taking those chunks and we'll be feeding them into our prompt. So remember earlier on, we did that prompt where we we did some experimentation in the playground, and you put in your instruction to the bot, which is basically, hey, you're a really annoying chatbot that argues emphatically for a flat earth. Answer the user's question based on this information, and then that's where we're going to now inject those chunks of information from the book, the most relevant chunks, 5 of them, into that conversation so the chatbot can answer it based on the information you provide. Hooray! So we're going to be using something called the Chat Completions API. And anybody use ChatGPT? Yay, all right. Well, in the background, there's an API, which is the Chat Completions API, which is something that you are going to use today. So what you do is you push a message to that. So you push the messages. So essentially, if you have a look at that, can you all see that, or do you need me to zoom in again? I'll zoom in anyway. So the important thing to know is that, and many people don't get this initially, but the completions API can deal with a whole string of turns of conversation. So you have the system message, which you used earlier in there, but you also have different interactions. So here's a user question. Oh, who won the World Cup, World Series? There's the assistant's reply. And then there's another user question here. So when you're hitting the API, you've got the whole context. You've got every turn of the conversation that you've had. We're going to keep it really simple because we're not going to do an ongoing conversation. We're just going to do a simple one question, one answer bot here. All right. So you don't have to maintain a list of dictionary entries with the different turns of conversation in it. All right. So when you do this, all you're going to have to do is update the system message with your instruction like you created earlier. You're going to have to inject the content from a query into it, and then you're going to have to specify in the API call what the user content is, i.e. what the question they're asking. All right? Okie doke. And then you get back a response, and within that response will be the answer that you want, and a load of other stuff which you'll have to filter out. Okay, that's the chatbot response. So in that you'll see that within that you've got a whole load of things like the things that you might be interested in. You'll definitely be interested in the answer, which comes in this bit, message, chat completion and content, and here you get where the answer is. You'll also get these things called tokens. Tokens are important to note because those are the things that tell you how much you're being charged for each hit you do at the API. And input tokens and output tokens are charged slightly differently. So it's a lower charge for the tokens you're inputting, higher charge for the tokens you're outputting. All right, good stuff. So I want to do a really simple flow, go through a really simple flow of where we're at with this, and then let you get on with it. You've got first section here to convert questions to embeddings. So, right, you know from what you've just been doing in the last exercise that if a question comes in, you have to convert that to an embedding before you can query the vector database, right? You know how to do that. You've done it. Then you query the vector database with the embedding, and you get back some results. And basically, you concatenate those results into a big, long string that you got back from that query with all the context in it. So it had different sections of the book, the different chunks that are relevant to answering the question. Now, the things we've got to do is inject that context into a system message, which we'll do, and then generate an OpenAI chat response. So there's only one module there's only one file to update in the next exercise. Oh, hello. Yeah, only one file to update, and that is basically this file here, which is exercise 4. If you go into exercise 4, there's the README file, and then there's this chatbot.py. So have a go with it. The easiest way to do this is copy and paste the code that you've just used into this exercise. So the idea is that we're going to use the exact same code we used in the last exercise to get the material back. If you just want to see it working, you can go into the solutions. So all of these come with a solution that should work. So the chatbot solution there, if you just want to see it working, we'll do it for you. All right? Brilliant. We've got 5 more minutes, and then just 2 minutes before the end, I'll do a quick roundup. And good luck, everybody. And yeah, raise your hands if you have any questions. Okay, guys. Literally, we've got 4 minutes before this session ends, and I'm sure some of you might have got to have complete. Did anybody actually manage to finish it off? Right. Have you got an example question and response there? Would you be happy to share your example question and response?
Why is the moon not flat?
Wait.
Why is the moon not flat though? Orally, you still don't get it, huh? Let me break it down to you. The moon being round or not has nothing to do with the Earth being flat. Just because the moon is round doesn't automatically make the Earth a globe. That's like saying because your toaster is square, your bread must be square too. It's called independent variables. Look it up. Also, just because the moon is round doesn't mean the Earth is. You are really stretching for an argument here. Next.
Oh, thank you. Give the man a clap. Come on. Great answer. Don't believe anything this chatbot tells you. Look, I understand it's a real squash to fit all of that into an hour and a half, but I hope you've got some of the information and some of the context you need to take the exercise home and do it in your own leisure time with a nice cup of coffee or a beer or whatever you like to do. Just as a wrap up, hopefully what you'll have experienced a really simple RAG scenario here where we've just asked a question, we've queried that vector data source to get the most relevant context. We've injected that into the prompt that we set the LLM. We gave that LLM an instruction. We gave it some data, some contextual data that could answer the question. And you'll see there that what a wonderful answer it came back with for our man over there. Hopefully you'll have some success with this. If you have any further questions, I've got some details there. I'll be around all day, and just I hope you have a really great conference, and thank you for being an awesome audience. Cheers. Thank you. Bye.